Okay, looking at a Year 9 Maths quiz, our quiz 4 for the term. So we've got a converting units question first up. Centimetres cubed to millimetres cubed. I know I'm going to times by 10 cubed there. So I would be doing 5 times 10 to the power of 3. Or I can do that as 5 times 1,000. But that will give me 5,000 millimetres cubed. Then we've got a perimeter question. So when we do that question, I'm going to use my highlighter to show you what I'm going to add up. So I've got this side is 11, this side is 8, and this side is 11. So if I add up all of that, but I also need that half circle there, and that will be half of pi d. So I've got the 11 plus 8 plus 11, and then I'm going to add to that a half times pi times 8, because the diameter here is 8. So when I add that up, I get 30 plus, and then 12.566. When I add that together, I get 42.566, which I can round to 42.57, and that will be metres. Then I've got an area question here. So I've got part of a circle, which means I'm going to use theta over 360 pi r squared, and my theta is 280. So I've got 280 over 360 times pi times, and my radius is 8 there. So I'm going to pop that in my calculator and do 280 over 360, and I'm going to multiply that by pi times 8 squared, and I get 156.38, and that will be metres squared. Then I've got a surface area question. Now I've got a cylinder here, which means my surface area is 2 lots of pi r squared for the top and the bottom, because they're circles, and then 2 pi rh for that wraparound rectangle that goes around the shape. So we've got 2 times pi times, now my diameter is 7, so my radius is 3.5, plus 2 times pi times 3.5 times, and my height is 9. So I get 76.97 there. And 197.92 there. So I'll add that together, and I get 274.89, and that will be metres squared. Then I have a volume question, and we know that volume is area of base times height. In this case, we already have been given the area of the base, so that's 20 multiplied by 5, so we get 100 metres cubed. Okay, going on to the second side, we have some triangle questions. So we start off with some Pythagoras theorem. So first up, we need to label our sides. So we've got A, B, C. So I can then write my rule, C squared equals A squared plus B squared. And I don't know what my C is, that's what I'm finding out. So I've got 7 squared plus 11 squared. So 49 plus 121. Sorry for that, guys. 49 plus 121 is going to give me 170. So I've got the square root of 170 gives me 13.04, and that will be centimetres. Now over here, I'm going to label my triangle with my A, B, C. So I've got my C squared equals A squared plus B squared, and in this case I've got 20 squared is equal to A squared plus 15 squared. So to get my A squared, I'm going to need to do 20 squared take 15 squared, and that gives me 175. So my A is the square root of 175. Oops. Then I get 13.22, and that is metres. Then I've got some trig ratio questions. So I'm going to label with my A, O, and H to start with. Now I know that they're trig ratio compared to Pythagoras because I've got an angle here now. So I have A, O, H. Over here I've got A, O, H. And here I've got A, O, and H. So in this case, I've got tan. Which is opposite over adjacent. So my tan of 70 is going to equal x over 5. The 5 is on the bottom, so I'll write 5 tan 70 equals x. Now, I'm just checking my calculator is actually in radians at the moment, so I need to change it to degrees. So now I've got 5 tan 70 gives me 13.73. And that should round to 13.74, and that is meters. Now over here I've got the A and the H, which means I'm going to use cos theta equals adjacent over hypotenuse. So my cos of 50 is going to equal 9 over x. The x is on the bottom, so we make them switch sides. So x is equal to 9 on cos 50. And I'll grab my calculator, do 9 divided by cos 50, and I get 14. And that will just round to 14 as the whole number, and that is centimeters. And then my lucky last one, I've got the O and the H. So I've got sine of theta equals O over H. Sine of theta is going to equal 7 over 12. So to get my theta, I'm going to do sine to the negative 1 of 7 on 12. So I'm going to grab my calculator, do second sine, 7 over 12, and I get 35.68. So I can round that to 35.69. I can probably round it to 35.7 degrees. Now we've got a bit of a worded question. So a hiker walks 7 kilometres north and then 10 kilometres west. And we want to find out how far they are from their starting point in a straight line. So what we've got here is a Pythagoras theorem question. So we've got c squared equals a squared plus b squared. And our x is our c. So we have got 7 squared plus 10 squared, 49 plus 100. So our c is going to be the square root of 149. So that's 12.2, and that will be kilometres. Now the next one says find the angle from north of their finish point. So that means we want this angle here. So when we do this question, we could use the measurement we've already worked out, but because you could have then a carried error, it's better to use the values that you've got if you can. So we've got the 10 and the 7, we can use them, use our tan theta equals opposite over adjacent, where we've got adjacent and opposite. So we've got 10 over 7. So if I do second tan of 10 over 7, I get 55 degrees. Now I could even go one step further. If that's the 55 degrees there, if I do 360, take 55, I can say that this part here is 305, which is what we would call a bearing for that angle that we're looking at when you're walking that the direction, and it's always clockwise from north. But the question just asked for that angle in there, so 55 degrees was our answer.